Alright, we're doing S7 review for the final with probability here. So Jaehee is playing a game and he's rolling a die. Okay, and when we roll a die, we're gonna get some answers, and I don't have any dice here. So, okay, well, whatever. Okay, so I'm gonna roll a die, and one side has a -3, another side has this, and so there are 6 possible sides I could get when I land on the die. And the score of the game is the number which lands face up when the die is rolled. So the following table shows the probability of the distribution. So all of these probabilities have to add up to 1. All probabilities add to 1, right? So I can say 1 over 18 plus 3 over 18 plus 1 over 18 plus 2 over 18 plus 7 over 18 plus p, that all has to add up to 1, right? So adding these all together, I'm going to get 14 out of 18. So that means that p has to equal to 4 out of 18, right? Because 14 out of 18 plus 4 out of 18 is going to give me 18 out of 18, which is 1. Okay. Jaehee plays the game once. Calculate the expected score. Okay, expected score. This was not on the last test, I don't think, but I have seen this on the final. So the expected score is when I multiply the score times its probability and add it all out. So I've got the expected score of a -3. I have to multiply that times the probability of getting a -3, plus the expected score of getting a -1 times that probability, which is 4 out of 18. The expected probability of getting a 0 is 3 out of 18. The expected value of getting a 1 is 1 out of 18. A 2, 2 out of 18. And 5 is 7 out of 18. Okay, so this is the expected value for getting a -3, a -1, a 0, a 1, a 2, and a 5. So if I simplify this, I get -3 over 18 minus 4 over 18 plus 0 plus 1 over 18 plus 4 over 18 plus 35 over 18. And if I add all of those together, I end up with 33 over 18, which means my expected score is equal to 1.83. Now, am I going to actually roll a die and get a 1.83? No. But on average, with these probabilities, on average, we would expect to get this score on average. Okay. Jaehee plays the game twice and adds the 2 scores together. Find the probability that Jaehee has a total of -3. So the probability of getting a -3. Okay, so getting a score of -3 means, to get a score of -3 means I have to get a 0, and I have to find the probability of getting a -3. So so either um, I'm going to get um, a score of -3 and then a 0, or I'm going to get a score of 0 and then a -3, right? So to get a score of -3, I've got the probability of 1/18, and the probability of getting a 0 is 3 out of 18. The probability of getting a 0 is 3 out of 18, and the probability of getting a -3 is 1 out of 18. So the probability of getting the number a score of a 3 and then a score of a 0, this probability um, is equal to 1 over 18 times 3 over 18, which gives me 3 over 324. And this probability is also 3 out of uh, uh, 324, isn't it? Okay, this is kind of a tricky question. This is probably getting a 3 first and then a 0, probably getting a 0 first and then a -3. And these scores, the -3 and 0, and this score is 0 and -3, they add up to a score of -3. Okay, so to find out the probability of getting the score, I have to add this and this together. So the probability of getting the -3, since the game is played twice, is equal to 3 over plus 8 out of 324, which gives me 6 out of 324, which simplifies to 0.0185, which, if I wanted to write this as a percent, I could write this as, move the decimal place 2 over. So any of these answers is correct. This answer is fine, this answer is fine, and this answer is fine. Okay, next page. Okay, you've got a class of 30 students, 19 play tennis, 3 play both tennis and volleyball. Okay, good, they gave us this value here. And 6 do not play either sport. Okay, we got the 6 out of here. 19 play tennis. So if 19 play tennis, that means these two have to add up to 19. So that means this needs to be 16, so that this one plus this one has to add up to 19. Okay. So there's 30 students total. So this plus this plus this plus this has to add up to 30. So the first thing I'm going to do is 16 plus 3 plus 6. That's going to give me 25. And then I do my 30 minus 25, and that's going to give me 5. So we know 5 students play volleyball, because this plus this plus this plus this has to add up to 30. Okay, so find the value of t. T is 16. Find the value of v. V equals 5. Okay, find the probability that a randomly selected student from the class plays tennis or volleyball, but not both. So 16 out of 30 plus 5 out of 30 is going to give me 21 out of 30. Okay, let's do the next one here. Andre will play in the semifinals of the tennis tournament. If Andre wins the semifinal, he will progress to the final. If Andre loses the semifinal, he will not progress to the final. If Andre wins the final, he will be the champion. The probability that Andre will win the semifinal is P. If Andre wins the semifinal, then the probability he will be champion is 0.6. So if he wins the semifinal, the probability he will be the champion is 0.6. So if that's 0.6, this is going to be 0.4. Right? So if that's 0.6, then that needs to be 0.4 because these have to add up to 1. Okay. The probability that Andre will not be the champion is 0.58. Okay. So if he's not going to be the champion, that means that's this pathway plus this pathway has to add up to 0.58. So this first pathway, P times 0.4 plus 1 minus P. These two pathways adds up to the probability of 0.58. Okay, so 0.4p plus 1 minus p equals 0.58. Okay, so 0.4p minus 0.4p is going to give me negative 0.6p. Right? Negative p minus 0.4p gives me this. If I subtract 1 on both sides, then I'm going to get negative 0.6p equals negative 0.42. And then if I divide both sides by 0.6, p equals negative 0.42 divided by negative 0.6. And then I'm going to get a probability that p equals 0.7. Okay, you might want to hit pause or rewind to think about that some more if you found that a little tricky. Okay, given that Andre did not become a champion, find the probability that he lost the semifinal. Okay, so given the probability he did not become the champion, find the probability that he lost the semifinal. Did not become champ. Okay. Find the probability that he lost the semifinal. So losing the semifinal, okay, the probability that given that he did not become a champion, so that is my given, and the probability that he did not become a champion is 0.58. Okay, what is the probability that he lost the semifinal given that he did not become a champion? So lost the semifinal is, okay, is this pathway here. Lost the semifinal, which is, this is 1 minus p, and p is 0.7, so 1 minus 0.7. and then we get 0.3 divided by 0.58 equals 0.517. This one was trickier than my usual conditional probability questions. I wouldn't worry too much about this one. We'll do other conditional probability examples that will be useful. Okay. Let's just talk these ones through. Okay. Synovecka plays 9 labeled balls shown in the box below. She then chooses 2 balls at random, one at a time from a box. The first is not replaced before he chooses the second. Find the probability that the first ball chosen is labeled A. So 1, 2, 3 of the 9 balls has the letter A on it. Find the probability that the first ball chosen is labeled A or N. So 1, 2, 3, 4, 5. Okay. Find the probability that the second ball chosen is labeled A, given that the first ball chosen was labeled N. So, if the first one chosen was labeled N, there are still 3 labeled A. And if it's not replaced, that means my denominator is going to decrease by 1. Find the probability that both balls chosen are labeled N. So if the first one is labeled N, there's 2 out of 9 that are labeled N. Now we've taken that one out, and now we've got 1 ball left, less, and there's 1 N left. Okay. On a school excursion, 100 students visit the amusement park. And we've got this Venn diagram. The students were asked which main attraction they visited, and the results are down below. Okay, so we've got these all numbers, and so if I add all these together, the 32, 9, 5, 12, 10, and okay, the total of 74 students visited roller coasters or water slides. So roller coasters or water slides is these here, not including the 18. Okay, so this plus this plus this plus this plus this plus this adds up to 74. Okay, so 32 plus 12 plus 5 plus 9 plus 10 gives me 68. And since the total number of students that went to these 2 things adds up to 74, that's how I figure out that this is 6. Okay. Now I can find the value of B. If I know that's 6, I can add all of these together. You already know that this is 74 plus 18. 74 plus 18 gives me 92, and there's 100 students, so now I know that this is going to be 8. Okay. Find the number of students who visited at least 2 types of main attractions. So at least 2 types of main attractions means this one, this one, this one, and this one. Because these ones that are green visited at least 2 main attractions. These 32, those 6, those 18, they only saw 1 attraction. They were boring children who only liked 1 ride. Oh my gosh. Can you believe such a tragedy? Why would they bother going to the amusement park? I don't know. Okay, write down the value, the number of people that intersected with R and W. So R and W, the intersection of R and W of roller coasters and water slides is um, is 9 and 5. So this is lowercase n means the number of people that intersected is going to be those added together. Find the probability that a randomly selected student visited a roller coaster. Okay, so the number of roller coaster visiting people are 32, 9, 5, and 12 out of 100. So adding the 32, 9, 5, and 12 out of 100 gives me this probability. Find the probability that a randomly selected student visited a virtual reality ride. So 12, 5, 10, and 18. Add those together. That's the number of people that visited a virtual reality ride. And then that gives us 45 out of 100. Hence, determine whether the event from this problem and this problem are independent. Okay, what does independent mean? Independent means the intersection of the two is equal to the probability of A times the probability of B. So the probability of riding a roller coaster is 58%. The probability of a virtual reality is 45%. And is that equal to, the formula says that is the intersection of A and B. So the intersection of roller coaster and virtual reality, is the only things that intersect roller coasters and virtual reality is the 12 and the 5. The 12 and the 5 is the intersection of this circle and this circle. Okay. This circle and this circle, the only intersection is the 12 and the 5. So this times this, I don't even need to use a calculator to know that this is not going to be equal to this. So that's where, and if I did use a calculator, I would get these values. So it is not independent. So when they're asking if something is independent, we need to use this independent formula. Okay. Remember, lowercase n means the number of things in that space. Okay, we've got some numbers here. And we've got a set here with integers 1 through 10. This means we're not counting 11, the number 11. So inside circle A is 1, 2, 3, 4, 6, and 8. Inside circle B is 2, 3, 5, and 7. Inside circle C is 1, 3, 5, 7, and 9. So the numbers that are in all three of them is the number 3. Okay, so I'm going to first write the 3 there. Let's do this on a blank one because this is harder to. Okay, so I see the 3, and the 3, so that number is in there. The 1 is in A and the C. The 2 is in the A and the B. 4, the number 4 is only in A. The number 5 is in the B and the C. The number 6 is only in A. The number 7 is in the B and the C. The number 8 is only in the A. The number 9 is only in the C. And there's no number 10. 10's out here. Okay. So write down the number of things in B. So the number of things in circle B is this guy, this guy, this guy, and this guy. So how many numbers did I underline? 4. So there are 4 numbers, 4 items in circle B. 4 numbers I counted. Okay. Complete the Venn diagrams. Well, I already did. Okay. Write down all the elements that belong to A intersection B prime intersection C. So A intersection B would be in here, right? But since it's prime, it's not in that space. I'm just going to cover it with my finger. Oops. Here. Those numbers we're not counting. A intersection. Oh, whoa, 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 whoa. A union B. A union B. And prime means not in that space. Intersection C is going to have to be the number 9. This is the only number that intersects with C, but is not in that space. Okay. Fun questions. Okay. Okay. We've got Sun Wang plays a game where she rolls a fair 6-sided die and spins a fair spinner with 4 equal sectors. So the spinner 1, 2, 3, 4, die 1, 2, 3, 4, 5, 6. The score on each term is the sum of the 2 results. For example, if a 1 on the die and a 2 on the spinner, the score is going to be 3. So if I roll a 1 and a 1, I'm going to get a score of 2. If I roll a 2 and a 1, I'm going to get a score of 3. If I roll a 3 and a 1, I'm going to get a score of 4. A 4 and a 1, a score of 5, and so on. 5 and a 1 is 6, 7. A 1 and a 2 is 3. Right? So if I roll a 6 and a 4, I'm going to get a score of 10. Okay, find the probability that the score is going to be greater than 4. Okay, so to be greater than 4, okay, not equal to, but greater than 4. So all of these that I'm highlighting, oh shoot. Let's start over. All of these that I'm highlighting in orange are greater than 4. So how many are greater than 4? 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 24. Okay. Sun 1 takes a second turn. Find the probability that the score is greater than 4 on both turns. So 18 over 24 is the first probability. The second one, same probability of getting greater than 4. So on both turns, the probability of getting greater than 18 is going to be. Okay. which is approximately. Okay. Sung Wong plays the game for 11 turns. Find the expected number of times that he's going to get greater than 4. Okay. We'll play the game for 11 turns. Okay. The probability of getting greater than 4 is this. And if he's going to play the game 11 times, and the probability of getting greater than 4 is 18 out of 24, then the probability of getting, that's going to give us 8.25. So the expected number of times, this is the expected number of times we should get a score greater than 4. Okay. Last question here. Okay. The diagram shows a circular horizontal board divided into 6 equal sectors. The sectors are labeled white, yellow, and blue. Okay. Notice the denominators stay the same because we're not removing anything when we spin. Okay. So the pointer is pinned in the center of the board, and the pointer is spun, and when it stops on a color, it's recorded. The pointer is equally likely to stop in any of the sectors. Eva will spin the pointer twice. Following the tree diagram shows all the possible outcomes. Find the probability that both spinners are yellow. Okay, so the probability that both spinners are yellow is going this way and then going this way. So it's going to be 1/3 times 1/3, which is going to be 1/9. Find the probability that at least one of the spins is yellow. So the probability that at least one of the spins is yellow is I could get blue and then a yellow, I could get a yellow and a yellow, and I can get a white and a yellow. Does that make sense? So that's the probability that at least one is a yellow. So this pathway gives me 1 yellow. This pathway gives me 2 yellows. This pathway gives me 1 yellow. So any of those routes gets me a yellow. So this route is 1/6 times 1/3 plus 1/3 times 1/3 plus 1/2 times 1/3. Okay. Now we're going to need a common denominator. So this denominator is, this is 1 out of 18 plus 1 out of 9 and then plus 1 out of 6. So my common denominator is going to be should be 18, right? So so I've got 1 out of 18 plus, multiply top and bottom there by 2. I've got 2 out of 18, I multiply top and bottom by 3. I have 3 out of 18. And I can add those all together. This plus that is going to give me 6 out of 18. Okay. Which means the probability is 1/3. Okay. Write down the probability that the second spin is yellow, given that the first spin is blue. Okay. So if it's given the first spin is blue, that means we were given this. What is the probability that the second spin is yellow? So given that we're in the first spin is blue, the probability that the next spin is yellow is going to be 1/3. Alrighty.